Hey, what's up? It's Jake from Nimbus DevOps, and now we're going to talk about filtering a comprehension. So, you can also apply filtering to list comprehension, and we're going to try it with just the regular filter function so you can see what it's doing in our way that we've been coding. Just like I've been doing, I will then do it inside of a list. So, let's try to do something fun. So, we're going to find all Pythagorean, oh my gosh, Pythagorean triples whose short sides are numbers smaller than 10. Sure, that's a useful thing everyone will do every day. Okay, so I'm going to say from math import the square root, so I don't have to mess with that. And then I'm going to say my max is going to be 10, and my triples is going to be, and I will make a list. And here we go. Go A, B, and then square root of A squared plus B squared. And then inside of here, let's see, triples A, B, square root A squared, B squared for A in range. And I'll say 1 and then whatever my max is. And then nest this in for B in range A max, A max. And this will give me what I need. But then I need to make another one that says triples equals, and then I'm going to make a list function, right? Let me break these up a little bit. Make a list function that says, hey, filter, and then do a lambda, and we'll just say triple, and then we'll say triple 3. No, 2. Triple 2 dot is underscore integer for whatever it is and triples. And then we can print triples. Okay, let's talk about what in the heck this is doing. Okay, so in here, and if you're looking at these all in one line, it just looks like this, right? So I import this object. I set a variable value 10 to the variable mx. And then you see I set a variable triples equal to a, b, square root, a squared plus b squared for a in range 1 through max, b in range a max. And then took that and said, we're going to print out essentially a list filtered with triple 2 is integer on triples. So this will have 3 tuples, triples. Each tuple contains 2 integer numbers, the legs of it, and then the hypotenuse of the Pythagorean triangle, whose legs are the first 2 numbers in the tuple. So like when A is 3 and B is 4, the tuple will be 3, 4, and then 5. When A is 5 and B is 7, the tuple will be 5, 7, and 8 point something. After you generate all the triples, we need to filter out anything where the hypotenuse is not an integer. So in order to do that, we filter based on the float number dot is integer being true. So that's what that does. This means that in the 2 example tuples we just went over, the one with hypotenuse 5 will actually be 5.0. It'll be retained, but the 8 point whatever will not be retained. This is good, so we should try it. Triangle. 3, 4, 5.0, 6, 8, and 10. So there you go. Those are all the Pythagorean triples whose short sides are smaller than 10. Pretty cool, huh? But the triple right now has 2 integer numbers and a float. and they're supposed to be integers. So we could use a map to fix this, and I could just comment this out real quick. Yeah, should I comment all of it out? No, we'll just add to it. Okay, so I got my triples, I've got my filter. So after it's been filtered, we're going to take triples and we're going to make a new list that has a map, and we're going to say lambda, let's see, triple, yeah, triple, and we're going to go :2 plus whatever int of triple at 2, triple at 2, comma, and then, yeah, comma triples. Yeah, I think so. This map triple shouldn't have, it should be a list. Let me break this up because this is getting crazy. And then a map with a lambda triple. Oh, I know what I did. Lambda triple and then triple. Triple. There we go. Now it's happy. Okay. So that should work. Let's take a look. Okay, there we go. So now it's going to take that and turn it back into an int. Okay. So what this is doing is saying, hey, on this position, index 2, so 0, 1, 2, so the third number, you want to just take this int version of this with this when you map it. So now it's an integer. So that might seem like a really convoluted way to do this, but it is in fact good. It's a good-ish Pythonic way to do this. It makes sense at least, right? So then the step that I added, you take the element of the triple, and we're slicing it, which is what that :2 is doing. We're going to take only the first two elements in it and then concatenate the slice with one tuple, a one tuple, like so one number. So if you look at this as this little code right here, this is like concatenation. So I'm hey, I'm gonna make a lambda called triple, and so I'm like, for triple, what we're gonna do is take the first two elements, right? So 3 and 4 in this tuple, and then add in that object this third element, which is just going to be this int version of the original number. So that's all we're doing. That's really all it is we just slice it, and then we're going to concatenate it, put it back together as an integer, and so that they all have the same data type. That's really it. So how would you do this same thing with list comprehension? Oh, I thought you'd never ask. So let's go delete. I don't. You know what? You never know when you need something. Let's just comment this out. And let's do the same thing with list comprehension. So I still have my from math import square root. I'm going to leave my variable declaration here. And I'm going to say triples equals, well, actually, I can just reuse this. Okay, so there's my triple. Now, I'm going to combine the filter and the map in one list comprehension. So we'll say triples equals, and then I'm going to go A, B, int C for A, comma B, comma C in triples if C dot is integer. Bloop. Okay, what am I missing here? Triples equals A, B, int C for A, B, O, C, comma makes all the world of difference. Okay, there we go. So this line of code replaces all of lines 9 through 13. So now if, in fact, if I just keep this part and stick it at the bottom, we get the same thing. So in this case, like this is nice, and it's actually way more readable than this. And you don't have to do some weirdo splice thing, right? So it's clean, readable, shorter. I don't think it's quite as elegant as it could have been though. Because you're wasting memory by having to construct a list of a lot of triples that you just end up getting rid of anyway, right? So we can fix this and we can actually combine these two things into one thing. So let's do that. So combined list comp. And this is where list comprehension becomes pretty cool. So I'm going to comment this out. We don't need this anymore. And we're going to say triples equals, get ready folks. All right, so A, B, int, C, which we did before. And then I'm going to say for, wait, let's get rid of that bracket. For A in range, and then we'll just say 1 to max. For B in range A to max, if C, oh, and we get to use the walrus operator, the square root of A squared plus B squared dot is underscore integer. Boom, and then close it. That would produce the same thing. Let's take a look. Boom. So now we just replace all this code with that, which looks kind of nuts. You know, you might want to break that up a little bit and have some kind of random. You can do it like this if you wanted to. When people say one-liners, it's like, it's a one-liner, but like, is it though? You know, like, maybe that's better. I don't know. But I'm going to leave it like this just so we can talk about it. So this is the most elegant way of doing this. You're generating the triples and filtering them in the same list comprehension, so you avoid keeping a triple that doesn't pass a test in memory. And we use an assignment expression to avoid needing to compute the value of square root twice, which is where the walrus operator came from. And even though I said we're not going to do this, I'm curious, how fast is this compared to the others? So let's try that. So let's take our timer and we get a stop, and then we'll print out the time. And let's go, okay, so how fast is this, right? And we're gonna ignore print for now. Oh, I need to do 2. I guess I need to do 2. We're gonna ignore print, and I'm gonna put these together because it just takes too much time, too much space. Okay, let's put these together so I can see what's going on. All right, so here we have a timer. We'll do time 1. And then let's start the timer here. And let's just compare this to the end and see how much faster they are. All right, and I don't care about printing the triples now. We already know that this works. Okay. You can see that not only is this way easier to read, it's way less lines of code. You could put it in one line like this, but it's faster. So everybody wins. Okay, well that is going to be it for filtering list comprehension. If you have any questions, let me know. Definitely play around with this. It's a lot of crazy looking code. You probably, when we started this, thought like, hey, we're talking about all this, but we're not like coding. But I think by going through this method, you learn everything you need to learn to do much more complicated stuff because the classes I've taken so far on Python have been very like hello world, let's concatenate strings and do some algebra or whatever. But we don't really get into this kind of stuff as deep. And so I kind of like this. I think that after like 6 weeks or 5 weeks or whatever, any Python course you're going to take, you're eventually going to get into list comprehension and reverse searches and all that other stuff. But this so far I think is pretty good. So we will stop there and go into some dictionary and set comprehensions.